In this video, we'll be looking at the examples from Chapter 5, Section 4. You should know the definition of a mid-segment and make sure that you're familiar with the mid-segment theorem before you do these examples. All right. Before we start any work, I want to take a look, as usual, at the diagram that we have here. I want to point out some things that I notice, and based on what a mid-segment is and some things that I know, I want to point out how those are going to be helpful. So our goal is that we are going to find the measurement of segment BD. I know it's a measurement, not just because of the word measure, but remember there's no little line above BD. And BD is this segment right here. Well, I need to establish, as BD is in the middle of an existing triangle, is this a mid-segment here? Because if it is, I know some factual things about it. So thing number one that I'm going to take a look at are all of these marks of congruency or of equal distance. And I see here that I've got these two segments that are congruent. So that must mean F is the midpoint of segment AE. I see that these two segments here each have 3 hashtags to them, which means they are congruent, and B is the midpoint to each of those. And then over here, these have 2 hashtags, meaning that D is the midpoint between of the segment CE. Because I've got a midpoint connected to a midpoint, that means that I've got a mid-segment. And based on the triangle mid-segment theorem, I'm going to be able to say some things pretty clearly. So the triangle mid-segment theorem helps me understand the relationship between segment BD and segment AE. I have a measurement for AE of 17, and what the triangle mid-segment theorem tells me is that from this midpoint to this midpoint is exactly half of the segment to which it's parallel. Half of that, they call it the third side over here. So I am going to take that yellow side, BD, and I'm going to say that that side BD, I'm going to go highlight in red down here, is 1/2 of segment AE. And I'm able to say that again because of the triangle mid-segment theorem. Now I just have a simple substitution where I'm going to take out AE, replace it with what I know, which is 17. I know that measurement is 17 based on my diagram. And I've got segment BD then equal to 8.5. Now in our second problem, we've got the same diagram, but we're being asked for something different. In this case, we're being asked for the measurement of angle CBD. So I've highlighted that in yellow. Now, one other thing that the triangle mid-segment theorem tells me is that, for example, in the previous example problem, we found the length of segment BD, okay, the distance from B to D. And the other thing that I know about BD based on the mid-segment theorem is that that segment is parallel to AE. So without having any parallel marks, without any feathers, I know that BD, if it's midpoint to midpoint, is parallel to the third side. So that means when I'm talking parallel lines, and I've got several sets of parallel lines here because I have right here BF, which is parallel to CE, And I also have FD, which is parallel to AC. So I've got several sets of parallel lines, which also means, if we think back to chapter 3, I've got all sorts of different relationships between the angles that are here. I am going to actually focus right now on, and I'm going to do these in blue, DF and CA. Because when I'm looking at the angles that I'm working with here, I know that I have this particular angle right here, angle 26. If I can really focus on the lines that I've highlighted in blue as two parallel lines, and I consider this segment here, BD, as a transversal between those two parallel lines, I can use the 26 degrees they gave me and start talking about alternate interior angles. So now, because I've been given the information and I have some information with regards to the mid-segment theorem, I can put all of those pieces together and establish the measurement of angle CBD. So I am going to make this a little smaller and move over so that I can write what I was just thinking about there. And the first thing that I was thinking about is establishing that segment DF. I'm going to go back and use my black ink. Segment DF is parallel to segment AC, okay, or CA. And I'm establishing that because the triangle mid-segment, I don't know how to abbreviate this, theorem, the triangle mid-segment theorem says that lines that are from midpoint to midpoint are parallel to the third line, so the line that they are not touching. With that, I also then can do exactly what I had hinted towards here, and I can start to look at this as a transversal. And I am going to establish that the measurement of angle BDF, which is the one that I knew, the one that was marked 26 degrees, is equal to the measurement of angle CBD. Now again, this is not necessarily a proof, but if we're thinking in those terms, the reason I can say they are equal to one another is the alternate interior angles theorem. I always write too big for the space I leave myself. Now, I'm going to do the same thing I've done with all the other problems it seems like we've been doing lately, and I'm going to substitute what I know, and that is that the measurement of BDF is 26 degrees, and then that is equal to the measurement of angle CBD just by substitution. All right, our last example is sort of a real-world application problem, and the only reason it's slightly more confusing than what we've done is that there are some things not marked here. This is an A-frame support. It just kind of looks like a ladder with a line in the middle. And part of what's confusing is that they're giving us information that doesn't match the picture they have. For example, they talk about the distance PQ being 46 inches in the problem. Well, PQ is down here from P to Q, and it's not marked at all with a line. However, it's a distance, and we know it's a distance, so we can fill it in with that little highlighted line that I have, and we can mark it 46 inches because it is. The other piece that they tell us throughout our reading, we're actually looking for ST, so I'll get my yellow highlighter. That's what I've been using when we've been looking for something, ST. And they tell us that S and T are at the midpoints of the sides. So there's another piece of information that we really haven't been given, and that is that the midpoint of this side and the midpoint of this side, right, are congruent to one another, and that is because point S is the midpoint of that particular side, and point T is the midpoint of that particular side. So even though our diagram looks a little bit lopsided, we trust the information we've been given. Now, all we're asked to do is find the length of the support beam that I've highlighted in yellow, the support beam ST. And we've already done something really similar to this. So we've got our triangle mid-segment theorem, which states that this support beam here is exactly 1/2 the measurement, right, of this bottom sort of invisible segment of the triangle. I know that it qualifies under the triangle mid-segment theorem, remember, because I've got a midpoint of the first side that is attached to a midpoint of the second side, which makes this the measurement 1/2 of the third side. So I'm going to set up a similar equation to what we used before, and I'm going to say that segment ST is equal to 1/2 the measurement of PQ. And if we know PQ is 46, we use simple substitution, and then we calculate that segment ST is in fact equal to 23. Our final answer, if we were doing a test, would probably be the support is 23 inches. Since this is a real world problem versus something where it's just asking about segment ST, we would answer with a full sentence.